All right, Algebra 1 students, welcome to your 6.3 notes on solving systems of equations by using elimination. Hopefully you enjoyed the short music clip from Stairway to Heaven. So, what we're doing here, this is basically, in elimination, it's basically an extension of the addition property of equality. But if we kind of just weed through all of the math jargon that's on the page, it's actually the most simple form of solving a system of equations. So here's what we do. Basically, I have a section lined up here that is a negative y and a positive y, and what I'm going to do is I'm basically going to add these two equations together. When I do that, these y's right here are going to cancel out, and I'm going to have an 8x is equal to 16. All right? And now what happens is if I solve for x, and we all know how to do that by now, I'm going to divide both sides by 8 so that I get x all by itself, which would be 2. And so now I have solved for x. I know what x is equal to. All right, and so now I need my initial equation to be a little cleaner. So let's clean this off just a little bit so I can kind of see both of them. All right, that works. I'm going to go ahead and pick one of the equations, doesn't matter which one, and I'm going to plug in my value for x, and then I'm going to solve for y. So let's just pick that equation right there. So I've got 5x, which we know to be 2 now, plus y is equal to 5. All right, so I've got 10 plus y is equal to 5. If I subtract 10 from each side of my equation, I'm going to have y is equal to negative 5. And I have solved my system using elimination. All I need to do now is list it in an ordered pair, just like that. And there we have it. All right, so in our second example, we don't have either one of those x's or y's that can simply just cancel out just like they did in the first example. So what I need to do is multiply one of these equations by something so that I can eliminate something. I'm going to choose to eliminate my y's because I've got a negative 2y sitting there. So I'm just going to choose to multiply this entire equation by 2. And right down here, I'm going to write what I come up with. So I'm going to have a 2x minus 4y. And a common mistake that I see a lot of people make, let me fix that equal sign. Common mistake that I see a lot of people make is they don't remember to multiply by everything in that entire equation. So if I multiply one side of the equation by 2, I need to multiply everything on the other side of the equation by 2. So 8 times 2 would be 16. So don't forget to do that side as well. Now, if I take a look at my y's right there, my y's will be able to cancel out. So I'm going to go ahead and add both of these equations together. I've got 4x. My y's end up canceling out. That's going to be equal to 20. And now I can solve for x. So I divide both sides by 4. X is equal to 5. Okay. Now I'm going to do the same thing I did on the first page, where I'm going to plug 5 in to one of these two equations and then solve for y. So I'm going to choose this first equation again. So I've got 5 minus 2y is equal to 8. And just so that I don't confuse people, let's put a set of parentheses around that 5, because that's what we've been doing on most of the substitution that we've been doing, because really what I'm doing is I'm substituting my my 5 back in for x. So here we go. Now I can solve for y. All right, I'm going to subtract 5 from both sides of my equation. So I've got negative 2y is equal to 8 minus 5, which is a positive 3. I can divide both sides by a negative 2, and I have y is equal to 3 over negative 2. Okay? And even though that's a fraction, that still works. I can write that as an ordered pair. My answer is 5 over negative 3 halves. All right? And that is my final answer for number 2. All right. Number 3. How am I doing on time? I've got plenty of time. Number 3, I'm going to choose, let's see. I'm going to have to multiply both equations by something in that one. So I'm going to multiply the first equation by 2, and the bottom equation I'm going to multiply, let's choose a negative 3. All right, and you guys will see what happens right over here. We're going to go this way with everything. So when I multiply the top one by 2, I get 6x plus 4y is equal to, let's see, it'd be 20 plus 14, so 34. Did I have enough room there? I think so. 6x plus y equals 34. Let's get a better looking plus sign right there. All right. Okay, so negative 3 times 2, that's going to give us a negative 6. Oops. Negative 6x. Negative 3 times 5y is going to give us a negative 15y. All right. And then I've got negative 3 times 26, well, that's going to be a negative 78. All right. And hopefully that shows up on my video there. A little bit off of the page. It's a good lesson about writing with iPads. We'll find out if we can write off the page and see it on the video. If not, there's negative 78 sitting there. All right, so in this one, my 6's are going to cancel out. I kind of saw that happening. That's why I chose to use 2 and 3. I was basically setting up something similar to figuring out what a common denominator is, but it's not exactly the same, obviously. So my 6's cancel out. I've got a 4 and a 15, so negative 15 plus 4 is a negative 11y. All right. And then when I take negative 78 and add 34 to it, well, that's a negative 44. And again, hopefully you folks can see my negative 44 there. Not quite sure whether or not you will, but there's negative 44 there. So now I've got negative 11y equals negative 44. Okay, I rewrote it there just in case you couldn't see it. Divide by negative 11 on both sides, so I end up with a y is equal to a positive 4. Negative divided by a negative is a positive. 44 divided by 11, well, that's 4. All right, not quite done. I need to plug that into one of my equations to determine what my x value is going to be worth. So let's choose the bottom one. 2x plus 5 times 4 is equal to 26. Okay, so 5 times 4, well, that's 20. Okay, 2x is still sitting there. I'm going to subtract 20 from both sides. So now I've got 2x is equal to 26 minus 20. Well, that's 6. Let's change color. I can divide both sides by 2, and x is equal to 3. And I can write that as an ordered pair, just like so. All right, in number 4, I'm going to choose to multiply this first equation by 2. So I'm going to end up with a 10x minus 4y is equal to 34. Okay, when I do that, watch what happens. My 10's cancel out, my 4's cancel out. I have 0 is equal to, let's see, what's this going to be? We have a 0 there. I have a 1 there, so I'd have 60. Is 0 equal to 60? Good question. I don't think so. So I'm going to say no solution in that case. All right. On to number 5, and in fact, what I want you to do is pause the video for number 5. Give that one a shot on your own. Okay, hopefully you paused your video and tried number 5 on your own. I came up with 0 equals 0 when I multiplied both of my equations. I figured out that everything cancels. So 0 always equals 0, so we have infinite number of solutions. You could also write infinity like that if you wanted to. Both of them work. On to the next one. All right, 2 families decide to attend the Olathe North musical. One family has 4 adults and 3 children. It costs them $47 for their tickets. Another family has 2 adults and 4 children, and it costs them $36 for their tickets. Find the cost for an adult ticket and the cost for a child ticket. All right, so this very last sentence right here tells me what I'm looking for. I'm looking for the price of the adult ticket and the price of the child's ticket. So we need to define our variables. All right, so we've got, I'm going to call the adult ticket. We're going to call that A. And we're going to call the child ticket, you guessed it, C. All right, so we're going to have in the first system of equations, we've got 4 A's and we've got 3 C's, and they pay $47. All right, and in the other family, we have 2 adults and we have 4 children. They ended up paying $36. All right, so there's our setup. We've got our setup done. What I need to do is multiply this second one by a -2. Okay, so when I do that, I end up with a -4A plus, it's not going to be a plus, it's going to be a minus, let's see, 8C. Sounds like somebody's taking the temperature in another room. And we've got a -2 times 36. All right, so that'd be 60 plus 12. 60 plus 12 would be 72. And that'd be negative. All right, so that I don't confuse myself, I'm going to go ahead and rewrite this other equation from the top right here, because I'm sure I will confuse myself if I do not. All right, add those 2 equations together. My A's are going to cancel out. I'm going to be, I'm going to have a -5C. I've got negative children. That's interesting. Okay, -72 plus 47. That is -25. And my negative children and my negative price are going to even out here in just a second, because when I divide both sides by -5, I end up with the price for my child's ticket, which is $5. All right. Now I'm not quite done. As most of you know, we got to plug in that 5 into the other equation to see what the price of an adult's ticket is going to be. So I've got 4A plus 3 times 5. That equals 47. All right, folks. I went really fast. You just couldn't see my pen moving. Actually, I was running short on time for my video, so I went ahead and paused it to do the rest of my math. There it is. I figured out that the price of an adult ticket is $8 because I took my price of a child's ticket and I plugged it in right there for C. That's how I did it.